So bleaching is like a fever in humans. We get a fever to resist a disease, and if the disease is not too much, we recover. But if it is too much, we die as a result. A bleached coral is not the same as a dead coral. Bleaching, because corals are symbiosis, they have single-cell algae living inside their tissue, and the algae gives them color. When they get stressed, it's a very high-energy symbiosis. It's very delicate. It's like a racing car. So as soon as they're stressed, both coral and algae can do a little bit better when they're separated. So they can separate voluntarily, and if it happens gently, it doesn't necessarily harm either of them. And then they can persist through the stress, and then they can come back together again, and the coral regains its color. So during that time, the coral is not growing as fast or getting as much energy as when it has the algae in it. Now, the problem is when the stress is too much. So they separate company, the coral is bleached, but the temperatures, for example, or sedimentation are just way too much. And as a result, the coral still dies, even though it is bleached to resist the stress.
What will happen is in the following years, depending on the species, the corals will start degrading because they are eroding. And this is when we will see the consequences. It might take even 10, 20 years to see these consequences.
It's pretty obvious that climate change is continuing to drive heat stress that coral reefs cannot cope with. The corals recovering and the new recruits into the communities are not adapting at a pace fast enough to keep up with the pace of climate change.